RiverTrail is the technology that we invented at Intel Labs. Today, there is a disconnect between HTML5 applications and the hardware on which they run. JavaScript applications are predominantly sequential. At the same time, hardware has many parallel capabilities. There are multiple cores, there are vector instructions, there is GPUs, and JavaScript applications can take advantage of this parallel hardware simply because there is no way to write the applications which would do this. So we propose to extend JavaScript with very simple and easy to use constructs which will allow web developers to write parallel programs, take advantage of parallel hardware, and at the same time avoid all the complexity and pitfalls that people who program in low-level languages like C++ have to deal with. We have very few APIs, which is on purpose because we wanted to keep things very simple. So what you need to do is to use existing data structures such as either array or typed objects, which you can use when you know what is the type of the data that you are using. This is the new APIs which are coming with ECMAScript 6 standard. And once you have, for example, an array, you can specify that you want to do sequential operations on each element of an array using map. If you want to do this in parallel, you just use map parallel method. And similarly, for example, you want to compute sum of all the elements. Sequentially, you use reduce, and parallel, you reduce parallel. We also have a couple of others, such as scan, scatter, and filter. Absolutely. Basically, there are two key benefits of parallel execution. One is performance, another is power efficiency, especially because parallel execution allows you to run on GPUs, and GPUs are known to be significantly more power efficient than CPUs. And in fact, for mobile devices, this might be much more important than performance, that once you run the code in parallel, your battery life is longer and you can just do more things on your device and get cooler things running.
Essentially compute-intensive applications, so things like computer vision, right, where you're operating on video streams or images, physics engines, you can do video processing, decoding, audio, image, essentially compute-intensive applications, I would say, rather than pure arithmetic. It is true that GPUs have fixed functionality for doing things related to graphics, but they're also very general computation engines. Typically, the way you would do general compute on GPUs is using languages like OpenCL. But our opinion is that languages like OpenCL are too low level and are kind of a poor fit for the web. So what our approach is to allow programmers to write in a very high-level language, JavaScript essentially, and we do the work of translating that into whatever API or whatever language is required to run on GPUs. So we essentially preserve the high-level nature of the programming environment, but we take care of the nitty-gritty details of running on GPUs. So that's how it works behind the scenes. Absolutely, yeah. So, for example, if you consider the case of a physics engine, right, where you have hundreds or thousands of bodies, and you have to detect collisions, and you have to animate these bodies according to the collisions. So collision detection is a very good example of a good compute-intensive but parallelizable operation that you could implement using RiverTrail. Dynamic simulation is also an example that also happens in game engines. But we also have other applications, for example, skinning and animation, right? You're often dealing with huge data sets, huge meshes with several thousands or hundreds of thousands of vertices. So these kinds of operations are also very suited for expressing through RiverTrail, and you can speed them up substantially.
Yeah, probably not directly, because everything you do on DOM is really hard to parallelize, because DOM interactions typically have a lot of side effects, and it's not clear what happens. So if you resize something in your DOM, or you insert a new element, that typically changes the layout of the websites or similar things. So directly interacting with DOM in a parallel fashion, that's not possible. But of course, all other kind of things you need to do, for instance, visual computations, like having nice effects on images, having nice transitions, doing some effects on videos, and particularly with WebRTC. So these kind of things that are not directly related to DOM, but still have a visual impact on your website, that's something you can certainly do. And we hope that there will be libraries and APIs and similar things that will allow you at a very high level to express these things and to make use of it. So you can still benefit from Rivertrail or parallel JavaScript, even though you don't directly write parallel JavaScript code through APIs. So it's still a relevant technology just for front-end web developers. So we initially did our prototype, which is on GitHub for you to download and to play with. And that was really just to show what's possible, so what can be done if you have this kind of technology in a web browser. It uses OpenCL, and it's really just a very rough cut of identifying what an API should look like, what the technologies are, and what the speedups are you can achieve. What we're doing with Mozilla is to really create a production quality implementation that really uses the JavaScript JIT engine, IronMonkey in that case, and that supports full JavaScript. So really the full features of the language. Our prototype was relatively limited to a small subset that was good enough for all the demos we wanted to do, but we realized it's not the language subset that JavaScript developers necessarily would want to use. So with Mozilla, we're really trying to push the boundaries to push it to the full level of JavaScript. And you can play with the results if you download the nightly build of Firefox. That has parallel JavaScript built in, currently on the array type, but we're working to have the full API implemented. And that will allow you to get some idea of what's possible and what it will look like in a browser once it's a final product. Yeah, I mean, web workers have already come quite away from how they were first implemented when they kind of came out in browsers. One big problem that people had with the concept of web workers is this not shared memory. So you have two workers and you communicate data by messages, which originally involved copying that data, which is very inefficient. And people were asking for having real shared memory with real threads for performance. But what people often forget is that also brings you all the troubles of threads, right? You get race conditions, you have to really be careful what you're doing, how you're mutating your state. So currently, I think implementers are moving in a direction to still preserve this distributed memory system with message passing, to not have shared memory, to keep all these demons of concurrent programming in the box. But making it more efficient by having transferable objects. So essentially, you can today already send a typed array to a different web worker, and it will not be copied, but the pointer will be passed underneath, and it will just become non-visible to the sending thread. And of course, you can try extend that ideas to ordinary objects, and there's people working on that. So I would expect web workers to become more lightweight and easier to use through libraries that are built on top of them. But I personally would find it very sad if there was full shared memory concurrency, because it would destroy one of the big qualities of JavaScript, which it's a concurrent programming model that's relatively easy to understand and very nice to work in. It would be sad if that would go away. So if you want to experiment a little bit with what the benefits of GPU execution are for JavaScript, then your place to go to is our GitHub prototype. It runs on Windows and macOS, and it's based on OpenCL, so you will need an OpenCL SDK installed. And that allows you to run on GPU. And we have a lot of workloads on that website too that you can explore. There's a tutorial which will tell you how to write your own workloads. So that's when you want to get into GPU. If you want to see the final API and the production level implementation, go ahead, download Nightly. That won't run on GPU, but it gives you still very decent speedups on CPU. We also have a GitHub repository with sample workloads for the Nightly prototype, and also a tutorial that will explain you what the API looks like and how to write workloads using video and image processing as an example. So we're very excited about this. This is a very, very exciting project, very close to our hearts. We think it's a great technology, but ultimately it's up to you to do something great with it. Also, we are working with the ECMA TC39 committee to standardize this, and Obviously, every comment is welcome. Play with the API, give us your opinion. Now is the time to shape it, to change it, and to get your feedback in.